Today we are going to be finding the area of regular hexagons and pentagons. So you should have out your 3-5 note sheet and taking notes off of Schoology there. So remember from geometry, we have some regular polygons here. The ones I'm looking at here are a hexagon, a pentagon. A hexagon there, the first one there, it has side lengths. There's 6 side lengths and they're all congruent to each other. They also have angles here on the outside, and these are all congruent as well. So, and the way, and then over here got a regular pentagon. It has 5 congruent sides, so all these sides here are congruent to each other. And then all of the angles in here are congruent to each other. Hence the name regular. So we're going to find the area of a regular hexagon or pentagon. I'm going to give you some information along the way to help you to figure out some details in there that aren't always given to you, but it seems that you know. So we could divide the polygon into triangles to find the area of a regular hexagon or pentagon there, and then find the area, and then find the central angle. So let's see, I could divide this hexagon into triangles, and then we're going to find the center angle. So to find that, how you can do, since there's 360 degrees in a circle, you can take 360 degrees and divide by 6, because there's 6 of them here in this hexagon, and we get 60 degrees. So each one of those angles I just marked is 60 degrees. We could do very similarly with a pentagon, divide this into triangles, and then to get these angle measurements, you can take 360 divided by 5, and you get 72. So each one of those angles in there is for 72 for the pentagon. These triangles are always isosceles at least. A pentagon, they'll be isosceles because these two sides right here will end up being equal. For a hexagon, it's actually all 3 of them end up being equal to each other, but it'll at least be an isosceles. And then find the area of the triangle. And how you can find the area of a triangle is you can use one of our nice formulas that we used from before. We've got 1/2 the base times the height. We've got Heron's formula, and we've got the trig area formula. And then once you get the area of one triangle, you can multiply by the number of triangles that are in that polygon to get the total area of that polygon. So let's go through and let's figure this one out here. The perimeter is 480 there. So we need to find a side length. So to find the side length there, I can do 480 there, and I can divide it by 6 to give me a value there of 80. So each one of these sides in here is 80. I'm not going to put them all in there. So let's also divide this into triangles in here, and I'm just going to put one of them in there. We could put them all in there. So let's also find the central angle in here. So we can do 360 here. There's 6 of them in there. Actually, I will draw it out. So you can see that there's 6 of them here. 1, 2, 3, 4, 5, 6. So 360 divided by 6 is going to give me 60 degrees up here. So we know that it's 80 and that's 60 there. And then we also know that this ends up being a nice little hexagon. It's a hexagon, so these are actually equilateral here. So this ends up being 80 as well. And the reason why I know it's equilateral is because these two here have to be the same that I just marked in there. So then these two base angles have to be the same. So all I have left, the sum of the angles of a triangle have to be 180. So I can take 180 minus 60 and I get 120 degrees. Well, 120 there divided by 2 there, because they split the 120 between the two, gives me 60 degrees. So we know it's a equilateral triangle there. So this one's 60 up here, and these are all 16 here as well. Don't really need those though. So let's go ahead and let's find the area of that triangle there. So to find the area of the triangle there, I'm going to use my semi-perimeter formula, my Heron's formula, square root, because we're given all 3 sides. So square root of semi-perimeter minus, or times the semi-perimeter minus the first side, semi-perimeter minus the second side, semi-perimeter minus the third side. So let's go ahead and find the semi-perimeter first of that. Semi-perimeter is 1/2 times the sum of the sides of the triangle. So the sides of that little triangle we just looked at is 80 plus 80 plus 80. And then to get the semi-perimeter there, we have to take it times 1/2 or divide by 2. And when we do that, we get 120. So now I can put the 120 into my formula here. Subtract off each of the 80s, because those are the length of their sides, are each 80. And when I do that, I end up getting about 2,771.3. And the total area, I'll just say area of hex. Area of the hex ends up being 2,771.3. And I got to take that times 6 because there's 6 triangles in there. This area only gave me the area of one triangle. We're trying to find the area of the hexagon. So we end up 16,627.8 about. I'm going to go to this one. So the perimeter of a regular pentagon is 150. Find the area of each triangle there. So if we go ahead and find the area of each triangle there, we got 3 of them this time. We got 1, 2, 3. So I'm going to work through these. The side lengths. So we know that that has a perimeter there of 150. Since there's 5 sides there, I'm going to divide by 5 and I get 30. So each of my side lengths in here is 30. And then I'm going to look at the interior angles next. Interior angles are these guys right here. To find those, I can take 180 times n minus 2, and n being the number of sides. So 180 times the number of sides of this pentagon is 5. So 180 times 3 gives me 540. So since there are 5 angles in there, in this pentagon, I can take 540 divided by 5 and get 108 degrees. So each of these angles in there is 108 degrees. So now that I know that's 108 degrees, let's keep moving on here. So I'm going to go ahead and find the area there of, and this is 108 as well. I can find the area there of triangle. Area of triangle 1. We'll do that again. So let's find the area of triangle 1 there, which also gives us the area of triangle 3. Area of triangle 1 there, since I'm given the 2 sides and include an angle, I'm going to use my area trig formula, 1/2 AB sine theta. So 1/2 times 30 times 30 times the sine 108. And when I end up doing that, getting that, I end up 436.6. And that's also the area of triangle 3. So determining now to figure out what the area there of triangle 2 there is. If we had that, we'd have the area of all our triangles there. So area of triangle 2 there, we need some more information. So I'm going to go ahead and I'm going to find this side length. I'm going to mark it here in red. I want to find that side length. So to be able to do that, I'm going to use my law of cosines there. because I need some more values over there. So my law of cosines there says a squared is equal to, I'm just going to call that a. To figure that a squared is equal to b squared plus c squared minus 2bc cosine a. So this is like angle A over here, and then these two sides here are B and C. So plugging those in there, we get a squared equals 30 squared plus 30 squared minus 2 times 30 times 30 times the cosine of 108. And so don't forget to take the square root of that, ends up being about 48.5. So now I can go ahead and determine what the area there is, that other triangle there. Because now that we have this to be 48.5, and these two angles in here by the red line there, those have to be equivalent to each other. So I can take 180 minus 60 there, not 60, 180 minus 108. And that ends up giving me 72 degrees for the sum of these two, but I got to take 72 divided by here 2, and I get 36 degrees. So this is 36, but this whole thing in here has to be 108. So I can take 108 minus 36 there, and 108 minus 36 there is going to give me 72. So this is 72 degrees. So knowing that, that's going to be a value I get to plug in there. So we've got, using our area trig formula now, because now we've got side here, the included angle, and a side here. So that triangle there, this is 30, this is 48.5, and this here is 72 degrees. So I'm going to plug those in there. I've got area equals 1/2 AB sine C, 1/2 48.5 times 30 times the sine of 72. Again, I had that side angle side situation, so I can use this formula. So when I do that, I get 691.9. To be continued on the next video.